Good evening, everyone. Thank you for joining us tonight for our latest medical sciences lecture titled Too Little, Not Too Late. My name is Nadia Tandy, and I'm an economics and business student here at UCL and your chair for today's event. In this lecture, Professor Montgomery will talk about the current climate situation and propose essential actions for everyone to take. We encourage active participation, so feel free to use the Q&A function on Zoom to submit your questions to our speaker. For those following on Twitter, the official event hashtag is hashtag FMSLectures. The lecture will be recorded and a link to the recording will be sent out via email to all the attendees after the event. Before I introduce our speaker, we would like to know about our audience, so we will be running a poll asking everyone to select the group you consider yourself to belong to. The choices are prospective students and their families, undergraduate students, PGT students, PGR students, PhDs, academics, patients and carers, and any other. Okay, thank you so much, everyone who has voted. The results are, we have 36% prospective students and their families, and that's 11 people. 3% undergraduate students, that's 1 person. Another one of PGT students, that also makes up 3%. We have no PGR students at all today. We have 7% PhD students, and that's 2 people. We have 28% academics, and that's 8 people. We have no patients or carers today, and we have 21% of any other, and that is 6 people. So I'm delighted to now introduce our speaker. We have Professor Hugh Montgomery. Hugh is a consultant intensivist in London and is Professor of Intensive Care Medicine at UCL, where he directs the Centre for Human Health and Performance. Hugh has chaired the 2 Lancet Commissions on Human Health and Climate Change, and now co-chairs the 5-year 42-country Lancet Countdown on Health and Climate Change. He was also appointed London leader by Greater London Authority's Sustainable Development Commission. He leads the Children's Climate Education Project Genie and co-led the ITV documentary on floods and climate change 2020. He was awarded the OBE in 2022 in part for his work on climate change and health. Thank you, Hugh, for joining us today. Now over to you.
Well, thank you very much indeed for inviting me, and I will share my screen. Good. Hopefully you'll be able to see that reasonably well, and welcome to you all, particularly as well to the students and prospective people who'd like to come to UCL. I can't commend it highly enough. The sort of work that I do couldn't be done in many other places because UCL encourages this sort of multidisciplinary work. You've heard my biography. I'm going to tell you the bad news about climate change because it's very, very frightening indeed. Whatever you thought, it's much worse than that. But I'm also going to try to tell you what we might be able to do because whilst we have done too little, with a bit of luck, it isn't too late. We have, however, ignored warnings. Here's a tsunami warning, which many people ignored over a decade ago, and they ignored the first waves coming ashore like this one and didn't think that was anything odd. They thought it might be a bit strange, but they decided to ignore it. And they ignored this one when it started appearing. And in fact, when the tide had gone right out, people were on the beach because it looked interesting. And when they saw this coming, some people ran towards the wave rather than away from it. Until this happened. And this happened. And then it was too late. Unlike a tsunami, though, the waves don't recede with the damage from climate change. Things get progressively worse. And the only way is to avoid that happening in the first place. And we have had plenty of warning. Over 165 years ago, John Tyndall at the Royal Institution told us about the greenhouse gas effect, that these gases let shortwave radiation through from the sun and trap longwave radiation. And he said, release of CO2 from burning coal, as had happened in the Industrial Revolution, threatened us heating our planet. But we took no notice. We ignored Henry Kissinger in 1974 when he warned us of climatic changes throughout the world if we didn't act. But we didn't act. And we didn't act 36 years ago when the world scientists met at the Toronto conference, saying that climate change was a major threat to international security already, and that we had to very rapidly drop our greenhouse gas emissions. But we didn't. Those warnings have continued, and I won't show them all to you. But what I will tell you is that in 2022, the Intergovernmental Panel on Climate Change warned us that any further delay in concerted global action would mean we would miss a rapidly closing window to secure a livable future. That's a future in which you and I might survive. So 2 years ago, we had to have acted aggressively and quickly if we were to live. But we haven't. Globally, we've put our hands over our eyes. We've not wanted to hear things. We've not wanted to talk of it because life is just a bit too comfortable for too many people. And the poorest in the world can't act anyway. So nothing's happened. Indeed, if you look at greenhouse gas emissions over time from 1850 to now, green is land use and the red is anthropogenic greenhouse gas emissions. Now on the x-axis going up to 40 there are gigatons. So those are thousands of millions, i.e. American billions of tons of CO2. Punching through 40. And in fact, if you add all of the other greenhouse gases that we emit beyond CO2 from all of its sources, they've been going up steadily, no matter what the warnings. And we've now reached nearly 54 billion tons every single year of these greenhouse gases we're emitting, if you count them over a 100-year life cycle. Now, just for reference, that's what 1 ton looks like. So imagine 53 billion of those going into a very thin atmosphere every year, because the atmosphere is thin. If you were to take the global gaseous atmosphere of the planet and wrap it up at standard temperature and pressure, it would be represented by that pink sphere. There's very little gas mantle around our planet indeed, and we're putting a very, very large volume of greenhouse gases into that small volume. And they stay for a long time. And this is one of the problems, that even if we stop emitting now, we're in trouble for millennia, because 1/5 of the CO2 we emit today will still be boiling our planet in 33,000 years' time, and 7% will still be boiling our planet in 100,000 years' time. There's a very long lag here. Yet we carry on. We keep putting more and more in every year, which means the concentration is continuing to rise from around 250 parts per million in pre-industrial times, and now this inexorable rise, and it's getting ever steeper. Indeed, in May of last year, we punched through 427 parts per million. And that jump in the last 2 years has been the largest 2-year jump we've ever recorded. So things are getting worse very much more quickly. And these gases are trapping a lot of energy, and it's energy gain that's the issue really, rather than just temperature. How much energy? Well, that's 1 Hiroshima bomb. And we're currently trapping somewhere between 5 and 8 Hiroshima bombs worth of energy every single second. And remember that when we stop emitting CO2 and other greenhouse gases, that continues, and it continues for a very, very long time indeed. We'll still be trapping 1 to 2 Hiroshima bombs of energy in 33,000 years' time, a result of what we've already released. And this is driving up temperatures. This is global average surface air temperature along the y-axis at the bottom between January and December, and each wiggly grey line as a year as temperatures rise and fall globally. Every year, the wiggly grey lines have gone up and up. And then look what happened last year. That's the orange line, 2023, an extraordinary and sudden rise. And we've continued on the purple line this year. And I've got these data for you, as you can see, from the 8th of June, from Copernicus. If you look at the anomalies, though, these are average temperatures on the left, but the temperatures are not rising evenly. You can see there that some areas are having anomalies of 12 Celsius above normal. And as we'll come to later, one of the big problems is the poles are warming 4 times quicker than the global surface average. And that, as you'll hear, is bad news. Here are the 30 warmest days ever recorded, and all of those were last year. And that trend has continued this year into 2024. Sea surface temperatures have done the same thing. Each of the grey lines again is a temperature anomaly from pre-industrial between January and December. Each grey line is going up. Look again at last year, 2023, this sudden lurch upwards. Look again at the purple line this year, still massively high. Look at that at the start in January, already compared to the January of the previous year, the orange to the purple. And again, if we look at the anomalies, they are huge. Because again, the rises in temperature and extremes are not evenly distributed. Those are the surface anomalies on the 8th of June. And you can see that some bits of ocean are north of 3 Celsius above normal. And we're talking here about huge volumes of water heated. Indeed, these data are Chinese, but the Americans have produced the same. And this is looking at the energy trapped by our oceans to a depth of 2 kilometers. That's measured in zetajoules. And I know that it will be hard for you to do the mental maths on zetajoules in your head. So just last year, we trapped the energy required to take 1 trillion Olympic swimming pools from freezing point to boiling point. That's the energy we trapped in our oceans last year. And remember, this isn't going to stop. This is causing all sorts of havoc. Not only are we getting these mass bleaching events, completely destroying ecosystems that will never, ever recover, and upon which our life ultimately depends, but it's driving water into the atmosphere, causing increased cloud cover, but that water has to come out as rain, and the latent heat of evaporation is released, driving ever worsening storms. Not just average air temperatures and sea temperatures, though, we're melting Arctic sea ice. This is Antarctic sea ice extent, which is progressively falling with that horrible lurch last year, just as we've seen for the others. A sudden dramatic change is now going on. We're seeing the Greenland ice sheet losing huge volumes of ice. And indeed, we're losing around 30 billion tons of ice every single hour from the Greenland ice shelf at the moment. We're losing it on land too. These are the data from the Swiss, that by last year, they'd lost 10% of their glacial volume in only 2 years. And remember, this takes thousands of years for glacial ice to form. If you melt land ice into the sea and you heat that sea, which thermally expands, sea levels will go up. And as you can see here, over time from 1993 to now, sea levels are going up, again, at an ever increasing rate. This is going to accelerate, and it's going to accelerate very dramatically indeed. We're now at 427 parts per million of CO2. The last time we were at 427 parts per million of CO2, sea levels were between 58 and 75 meters higher than they currently are. If you add energy to an atmosphere, you get weather. The more energy you add, the more weather you get. The more extreme weather events you get, and the more extreme are those weather events. And as you see, they're also becoming increasingly frequent, exactly as you would expect. Let's just very, very quickly run through them, because this has almost become like wallpaper to us now, hasn't it? We just accept extreme weather. Top left there is Australian summer, our Northern Hemisphere winter, 2019-20. And that released a huge amount of CO2, just the fire in just one continent, in just one province, in just the east, in just one season, added 6% to global greenhouse gas emissions that year. But it wasn't the only fire. Indonesia was ablaze, Siberia, Angola, Congo, and the Amazon. 2021, Canada was ablaze, and the whole of Northern Europe. We then moved straight through into the summer of 21. Australia was flooding. Top left, the Belgian-German border. Top right, Germany was flooding. London was underwater 3 times. Tens of thousands died in Beijing in the middle there. The bottom left, the iconic pictures of the New York subway. British Columbia flooding in December. Malaysia displacing in the end nearly 100,000 people. And then suddenly in 2022, we're back to heat. Huge heat waves in India and Pakistan, where the joke was, if you died and went to hell, you should take a blanket because it was colder there than on Earth. But the heat waves again, record temperatures in Britain, record temperatures across Europe, record temperatures in Japan, Korea, and China. The same year, though, that we had record rainfall, highest density rainfall ever recorded in KwaZulu-Natal in South Africa and flooding. Spain and Valencia, highest density rainfall ever recorded. There's Pakistan, the bottom left, not just ablaze that year, but the same year that 1/3 of it was underwater. The same with the flooding in Venezuela, in Nigeria displacing over 500,000 people, and the highest storm surge ever recorded in Florida. By January of last year, this was the picture on January the 1st in Bilbao. Temperatures normally 10 Celsius. They were 25 Celsius that day. And we moved through last year watching France, and Switzerland, and Italy drying out. By the summer, Canada was ablaze, and the smoke was causing this effect in New York. By July, we had flooding in New York and Oklahoma, Korea, India, and Spain, followed by record temperatures again in China, in Japan, and Korea, with these fires that you might remember from Corfu, Las Palmas, and so forth. By August, China's underwater again, Canada's ablaze again, Hawaii has caught fire, Greece is flooding, Hong Kong is in trouble. And in South America, the winter temperatures were higher than their normal summer temperatures. And then we move to this year, and things have got no better. This was Chile in February, temperatures normally 21, now 33, with massive fires, massive floods and landslides in Los Angeles County, Switzerland without snow, Catalonia, reservoirs down to only 16% of their normal volume, Texas having its second biggest wildfire ever recorded, around 2 years of rainfall happening in 16 hours in Dubai, millions flooded in Guangdong, followed again by flooding in Dubai again. And you've heard now of the flooding in Brazil that's been going on that's killed so many. So things are continuing to worsen. This paper in Science was warning us that the very underpinnings of our survival as a species are now threatened. Once we punch through somewhere between 3 and 5 Celsius of temperature rise, we end up with a mass extinction event being triggered by the end of this century. And remember, the Permian killed 96% of life in our oceans, and that would certainly do for us. The point being that 1.43 Celsius, which is where we are now, as an average 10-year cycle of temperature rise, is clearly desperately unsafe. The idea that 1.5 degrees was going to be safe is a fallacy and is lunacy. We're already in terrible trouble. And remember what I told you, things are going to continue to get worse because these greenhouse gases don't go away fast. Remember that I also told you the IPCC had warned us, unless we took this really seriously right now, but that was 2 years ago, we risk being in a situation where we had no livable planet on which to survive. And yet we've done nothing at all, you and me, our politicians, our businesses, but we as individuals. This is what humanity burned last year. And we continue to burn more and more, as I showed you earlier. But it's worse than that, because we've now triggered a multitude of positive feedback loops that are causing the planet to experience runaway heating. The first is the melting of snow and ice, which would normally reflect heat back into space. That's known as the surface albedo effect. The melting of snow and ice means there's less to reflect heat back into space, but there's more dark land and ocean to absorb that heat, meaning we probably doubled the rate of Earth's energy gain in the last 14 years or so. The fires release CO2. CO2 is a greenhouse gas, which traps more heat, which causes more ice to melt and causes more fires. How much CO2 is staggering. In summer of 2023, just those Canadian fires added 6% to anthropogenic greenhouse gas emissions. And remember, it wasn't the only fire on the planet. There are very, very many more. The fires also release carbon monoxide, and that mops up hydroxyl radicals. Hydroxyl radicals would normally clear methane from the atmosphere, and methane is 83 times as powerful a greenhouse gas in its first 20 years as is carbon dioxide. We're also releasing a lot of methane from melting clathrates and hydrates, from carbonate rocks and frozen tundra, and from fermenting wetlands. Together with that release and the failure to clear it, because we've cleared hydroxyl radicals from fires, the methane concentrations are going up very steeply. This was where we've reached. Most of methane, of course, is coming from natural gas, which was a phrase used by the fossil fuel industry to make you like it. Natural gas is methane. And you'll see that we reached a new equilibrium level somewhere between 2000 and 2010. But with these positive feedback loops, this is what we've now seen, with this rate of rise accelerating even more. When we evaporate water from the oceans, but we inject it into the atmosphere with storms, it acts there as a greenhouse gas, another positive forcing effect. And meanwhile, the rainforests are drying out and they're catching fire, even if we're not setting light to them deliberately, losing 16 soccer pitches to fire every single minute. That is also releasing a great deal of CO2. We're warming ecosystems, which are now fermenting and releasing more CO2 as well. Worse still, though, weather events go from binary state change when the climate changes. So things don't just necessarily progress progressively. And you'll remember I showed you earlier on those sudden jumps in temperatures and ice melt and other metrics. And it's this sort of binary weather state change that underpins that. You might remember also that I told you that the poles are warming around 4 times more quickly than the rest of the global average. And that can dramatically accelerate in what are known as Danskard-Oeschger events. There's one in the middle that I've highlighted there around 38,000 years ago, when temperatures jumped by around 12 Celsius in a very short time period indeed. This particular paper took us to the right-hand side of that graph, saying the little pink star is where we're at, and said that we had triggered a DO event, and that if we had triggered that DO event, we're looking now at temperature rises in the poles around 35 Celsius in very short time frames indeed. Now, you might say, well, Hugh, let's just hope that we haven't done that. The trouble is, all the evidence says that we have. This was March the 21st in 2022, when the temperatures in Antarctica were 40 Celsius above normal. And in the North Pole, temperatures were 30 Celsius above normal. Sounds bad enough, except the next day, temperatures in Antarctica were 47 Celsius above normal. And that'd be bad enough if it only happened the once. But these sorts of temperature surges are now happening regularly. Indeed, throughout that summer season of June 2022, average Arctic temperatures were 32.5 Celsius. That's plus 32.5 Celsius, when they're normally around 13. This is Greenland, which in 2022 saw this massive sudden melt. The grey are each year getting worse. The global average right way through from 1981 to 2010 is the blue line. The red line was that year, with this sudden surge in the first weekend of September, which was 20 Celsius above normal temperature, losing 20 billion tons in one weekend. That's 7% of the total Greenland normal ice melt over a year, happening in 2 days. Bad enough if it wasn't the second year in a row that had happened. Bad enough if this isn't what happened last year. So 3 years in a row. And you can work out, if these temperatures rise, what that means to ice melt. Because in fact, even if you have a transient rise around 1.7 to 2.3, you can trigger abrupt ice sheet melt. Because what you end up doing is melting water beneath the ice, which causes it to slide abruptly into the sea. And that's irrevocable, even if you drop the temperatures back down. And as this paper says, even temporary overshooting leads to very dramatic rises in sea level. And it looks very much as if that's what we've done. We're also disrupting ocean circulations by melting cold, fresh water into warmer, salty water. This ocean circulation is the Atlantic Meridional Overturning Circulation, or AMOC, dragging in warm water from the Pacific up past the north of Australia, through southern Africa and up past Britain as the Gulf Stream in the top left there. And it's that, of course, that keeps us free of icebergs in the winter, when on the same latitude directly west, Newfoundland has those in the winter. We're looking as if we're weakening that. Collapse of this ocean circulation would be absolutely catastrophic for weather. And we now know from multiple papers that we're at a point close to a critical transition, when it could actually happen as early as 2028, although hopefully it might be a little bit further on. But even so, when it happens, it will be catastrophic. It will cause sudden cooling in the northern hemisphere as the rest of the planet heats in the context of very extreme temperature driven weather extremes. The jet stream, which you hear about now in the news quite a lot, is a high altitude river, as it were, of water laden air at the junction of colder Arctic air and warmer southern air. As the Arctic is heating 4 times quicker than the southern air, that jet stream is moving north. It's normally driven by the Coriolis effect of the Earth's rotation, but it's moving north and it's becoming unstable. That means that the Iberian Peninsula, so Spain and Portugal, southern Italy too, is being deprived of rain. This is what's causing these progressively severe droughts there. It's also what's dumping that water on northern Europe. And while we had such a bad wet winter this winter, leading to loss around 10% of revenue from British agriculture, around 1.2 billion in costs. If you get extreme weather events, an unlivable climate, starvation, you also get economic collapse. And together, these cause massive societal disruptions, cause migration, and they cause war. You'll notice that I'm not taking you through all the data from the Lancet Commission and countdowns about dengue fever, malaria, diarrheal disease, Vibrio, and other effects, because they fade to insignificance when we compare them to the impacts of mass migration, war, economic collapse, and starvation. Indeed, UNICEF tell us that we already had 43 million child displacements linked to extreme weather events in the last 6 years. And we know that just if you look at static temperature rises, around 18% of the world's surface area currently occupied by humans will be uninhabitable. They'll have temperatures above those of the Sahara, where people cannot live. Currently, that's around 0.6% of the world's surface area, and that's going to move to 18% of the surface area where people live. You're also going to get massive displacement from high tide, as well as from extreme weather events. Billions of people on the move. And indeed, even 3 years ago, before the data became quite as terrifying, the Intergovernmental Panel on Climate Change were warning that species extinction, widespread disease, unlivable heat, ecosystem collapse, cities menaced by rising seas will be painfully obvious within the next 30 years. That doesn't mean after 30 years. And we can already see these things happening now. It's worth commenting on the economic collapse because some of these things are framed as being soft thinking from ecologists and from climate physicists, although climate physicists are very hardcore scientists. Economists are also worrying us with their data. This was Pakistan with its flooding, to which we spoke of earlier on, a $16 billion hit, 2.2% of its global domestic product. The droughts in the United States plains and heat waves, 9.4 billion. 15 confirmed extreme weather events with massive losses, according to the National Centres for Environmental Information in the States. The Canadian fires in June knocked agriculture, forestry and fishing down by 3.5%. It hit income from accommodation and hotels, from mining and quarrying, and from ore production, rail travel, and indeed huge losses. In Europe, the heat waves that year cost us 13.4 billion euros in losses that year alone. The Florida floods, another 18 to 20 billion. Indeed, we're losing around $4,500 per second for the world economy already. And we've lost something in the region of 4.3 trillion in recent years from the world economy. And remember, things are only going to get worse. Indeed, the Basel Committee on Banking Supervision said that climate change is now a threat to the very stability of the banking system itself. Lloyd's of London, the insurers, in October of last year, are suggesting that we're risking potentially 5 trillion in extreme weather events over the next 5 years due to climate change. In fact, the risks of an extreme weather event worth far more are substantial. There's a 1 in 300 chance now in the next 48 months of a single extreme weather event taking $17.6 trillion off the world economy. That's around a fifth or a sixth of the global economy disappearing in a week. This paper came out in Nature only 3 weeks ago, saying that static temperature rises on their own without the extreme weather events means we're committed to the loss of a fifth of world's domestic product within the next 20 or so years. Indeed, if it's as high as 29%, we're committed to 19%. That means we'll lose 38 trillion per year from the world economy in around 26 years' time. That's a third of the global economy disappearing. That means there won't be any education, there won't be food, there won't be hospitals. Indeed, the Institution Faculty of Actuaries and Insurers last year said, and I'm quoting directly here, our economy may not exist at all if we do not mitigate climate change. They also point out we've left it too late to manage things incrementally. We now need transformative change. And let me remind you, if we don't do that, we're not going to survive, you and our children. And yet the conference, the parties, negotiations, the world leaders, last year removed any ambition to even peak emissions. We have far less time than we thought too. In fact, it appears that if you go back to 1800 temperatures as the baseline, we've already breached 1.5 degrees on a 10-year rolling average. And by 2028, we will have breached 2 Celsius. It's worse still than that, though. This is Jim Hansen from NASA Goddard. He thinks that we've underestimated what's known as radiative forcing, the heating due to greenhouse gases, by a factor of 50 to 100%. And as he points out, 1.5 degrees of target is, quote, as dead as a doornail. We're now on target for 10 Celsius. And let me remind you what we've got with 1.43. So this is catastrophic. It is the end of the world as we know it if we don't act. It's certainly the end of human civilization. It may well be the end of the global ecosystem upon which we depend and life on Earth as we know it. And we have all been responsible for this by the way we've behaved. So this is my call to arms as I finish now. We need to do something about this because it isn't too late. But it is too late for minor change. We have to throw absolutely everything at this right now. We need to stop all our greenhouse gas emissions, and we need to be drawing CO2 out of the atmosphere at huge scale. That's what net zero is meant to mean. It's meant to mean that we cut everything that we possibly can, and then we draw down CO2 that we're still emitting and more to lower the concentrations in the atmosphere. But there is currently no commercial system that will do that. And we removed 1.6 million metric tons from the atmosphere last year when we released 50 billion metric tons. So it isn't too late, but it does require every single one of you listening to this today to deeply commit to taking the action that's required. That's the first thing you need to do now, is commit in your heart, decide that you are going to address this. Then you need to get on and do it, and you need to lead others to do it. And it has to start here, today and now. I'm going to give you the language of the negotiation so you know what to do. Scope 1 are your emissions that you're responsible for directly burning greenhouse gases. So that's petrol or diesel in your car, it's gas in your boiler at home, it's coal in a fireplace. We need to stop all of the above. So in your car, that's moving to electric vehicles where the power comes entirely from 100% renewables. It's getting rid of our gas boilers. It's putting in air source heat pumps. These things are expensive. It's getting rid of your gas cooker. It's not small beer, this stuff. I appreciate this is expensive stuff, but we have to do it. Scope 2 are the emissions for which we're all responsible that come from the power we buy to run this computer that I'm broadcasting on now, or to light our homes, or indeed to heat them. So we need to move our greenhouse gases, or our power supplies rather, to 100% renewable. So if you haven't done that, you need to be moving to, let's say, Good Energy or Octopus Energy, a company that will provide you with 100% renewable power. And you need to do that tonight. It will take you 20 minutes. Then we've got scope 3. That's everything we procure to happen, or everything that we do that makes other things happen. Travel, for instance, we need to be walking and cycling or not traveling if we can avoid it. If we are traveling, we need to take the train and mass transport. For instance, the Eurostar, because it's nuclear electricity that provides that, that's only 8 grams of CO2 per kilometre, and walking is 6 grams of CO2 per kilometre. But we must not be flying if we can possibly avoid it. We need to change our food. Methane, as I pointed out, is a very powerful greenhouse gas. It's quite short-lived, though. So if we stop emitting it, the concentrations fall fast. And a large amount of that food, methane, comes from the food supply. Food manufacture, of course, is also expensive. Cows belch methane, as do sheep, and that's very powerful greenhouse gas. And pasteurization of milk and dairy products means flash heating milk to 73 degrees and flash cooling it to 4, and then chilling it for its entire route. So we need to stop eating ruminant meat. We need to try to reduce our dairy as much as we can. And we need to eat plant-based diets that are largely seasonable and local, because that means that we aren't heating greenhouses to produce the food, and we're not having air miles to ship them. And you may have heard indeed on Radio 4 this morning, reporting on a paper saying that moving to this Planetary diet, as it's called, from the Lancet Eat Commission from a few years ago, adds potentially 4 years to your life. You need to move where you've got your money. If you're with most of the high street banks, you are bankrolling our own death by funding fossil fuel extraction. And you can move to a bank like the Cooperative, or a building society like Nationwide, or an online bank like Monzo that doesn't invest in fossil fuels. And if you do have investments, you need to move them out of the fossil fuel companies. And many charities, in fact, most, I would say, have done this. Most major universities have, and indeed all the charity boards I sit on, and there are 5, have all moved their investments too. So you need to do that as well. And we need to think about what we buy. Do we need to buy anything at all? Are there things that we just can do without? And if we are going to buy things, can we buy secondhand? Can we recycle and reuse them? Can we buy them from a company that's trying its best to minimize the carbon footprint? Now, this may all sound meaningless. You may say, well, my next door neighbor won't do any of that, even if I do. Or we say, well, if we do that, China and India won't, or someone else's government won't. But we live in an age of consequence. We must all take responsibility now for our own actions. And we all have to take responsibility for doing the right thing. There was a day when we all tried to do the right thing. This is one of those times. So we must all take this and make these actions, and we must lead others to do so. Because we can be the villains of the piece if we don't. And we will have blood on our hands unless we do. But to quote David Bowie, if we do take those actions, we can be heroes forever and ever. What do you say? Thanks very much for listening.
Thank you so much, Hugh, for the fascinating lecture. And now we'll be moving on to the Q&A part.
Sure.
So we have a few questions that's already come through. The first one being, how does countries with limited healthcare services could be better prepared for the mental health impact of climate change?
The mental health impacts?
Yes, the mental health impact.
I'm not sure that's an easy question to answer, because whilst I appreciate that we are committed to awfulness coming our way and that we should in some way try to prepare and adapt, I think we can't adapt our way out of this. I think the focus has to be on mitigating. And I'm not sure that me telling someone who's feeling distressed because they've lost their house, their job, they can't feed their children, that me telling them that I can help their mental health is going to be of any use at all, because I don't think it will, because there's nothing I can do to fix their house, their economy, and their children. So I think we have to focus much more on getting on and stopping this catastrophe coming our way.
Definitely. Now on to the next question. What degree is the Earth currently at, and how does this compare to past temperatures?
Well, I think I'll just refer you back to the graphs I showed you and the numbers. We're 1.43 Celsius on a 10-year rolling average above pre-industrial. And I've explained that it's not about the temperatures, it's about the energy gain, which is 5 to 8 Hiroshima bombs worth of energy, 1 trillion boiled heat swimming pools a year. So yeah, those are the data.
Okay, the next question we have, can we reduce the amount of carbon and greenhouse gases in the atmosphere at the moment, or do we have to work on reducing the amount going into the atmosphere?
Quite simply, you have to do both, because the time for which they last is enormous. So we have to go very quickly to zero. And the Paris deal, which everyone signed up to aspire to, which didn't mean they would do anything, and they haven't, means that we should already be reducing and withdrawing CO2 from the atmosphere. So we have to do both. We have to stop emitting, and then we have to draw down those concentrations, because otherwise those concentrations will stay high for a very long time. Now, this is no mean feat. To decarbonize our economy at the moment will require somewhere between $3 and $5 trillion a year. But bear in mind, I've already pointed out that we risk in the next 48 months, a 1 in 300 chance of $17.6 trillion hit. And we're going to lose $5 trillion in the next 4 to 5 years anyway. So this is a manageable sum, but it's a lot, 3 to 4 trillion. But on top of that, we have to try to develop and deploy carbon capture and storage to draw CO2 out of the atmosphere. And that in itself will be a challenge, because not only do we need to develop and deploy the technology, but we need to power it. And that means we're going to need an awful lot more renewable power to power the technology that draws the CO2 down. So this is a huge undertaking. And it's a reason to be pessimistic in many ways about our chances of success, because we've got to do both of those things, and we've got to do them both right now.
That is very insightful. Thank you. So this is a question about perhaps more so your journey. So how did you transition from being a doctor into what you do now with health and climate change?
That's a good question. I suppose I still am a doctor. I still practice around 25% of my time on an intensive care unit, and I still do research. But I stumbled into the science a little bit by accident, and the genetics we were publishing in the late 90s was appearing in the big journals Nature and Science. And if you've ever read those, you'll find that there's the article about what you're interested in, and next to it is something totally different. It might be about fossil hominids or string theory or quarks. And quite often those articles look quite interesting. So I started reading those. There are quite a few on climate change that looked frankly terrifying, but it was a time when the newspapers were all saying, well, there's probably nothing to worry about. So I spent a couple of years studying the climate science to try to understand what the truth was. And when you study the science, you realize things were far worse than even we've been told. So that's how I got into it. And I think you then have a decision to make. And it's really what I came to at the end, that you can't unknow things. And if bad things are happening, we all have a moral responsibility to intervene to stop them, don't we? Whatever it is that we find in life. Just climate change happens to be one of the very much bigger things, that's all.
Okay, the next question we have from the Q&A box. When making the case for the charities you are involved with to divest their investments, how did you convince them they would still be meeting their charitable obligations and manage fears about reduced returns on investments?
Well, I mean, firstly, quite simply, it doesn't matter, because investments aren't the metric. It's your survival and mine, and that of our children, that matters. And this is the nonsense question that we get from banks and others. They say, yeah, but what happens to my returns? Returns are irrelevant. They're irrelevant because the economy will collapse as a result, and the investments will be worth nothing. And no one will be alive to enjoy the returns on investment anyway. So the first thing is that that's a null argument that needs to be dispelled. As it happens, then the second argument would be, is it morally the right thing to do? And it evidently is. And the third thing is, can you still get a return on investment by investing in the good stuff? And the answer is you can. The charity boards on which I sit would have made more money when Russia invaded Ukraine and there was a spike in fossil fuel prices, but that itself would have been blood money and we wouldn't have wanted it. We're making a very respectable return from renewable-based, non-fossil fuel-based investments in all of those charities. And that's been across the board from Windsor Castle, St George's House, through to the Intensive Care Society in Great Britain, and most major medical charities now, the Wellcome Trust have divested, and others too, because they realise it's just morally wrong.
So following up on this, what can we do as individuals to encourage political parties to pay attention to this matter?
It's a really good question, really, really good question, because quite clearly we failed, haven't we, to convince politicians. And that's partly because politicians of any colour are frightened by the sort of question we just got. Well, what happens to my return on investment? What happens to my economy? Well, it's the wrong question. What happens if you don't act? So we need to start voting differently and making it clear why we're voting that way. And we need to accept that if that means that there are increased charges or taxes in different places, we have to accept them, because the consequences of not investing to, let's say, decarbonize our grids is going to be catastrophe for all of us. The second problem, of course, has been that this area has got very politically coloured. So very many people of the more far right don't believe in climate change for political reasons, not for intellectual ones, and refuse to even hear the data. And without being too indiscreet, there are people who've been in government in recent years who refuse even to listen to data. I think we can't change them directly other than by changing our behaviours. If we all start changing where we spend, moving our bank accounts, moving our power supplies, writing to prospective parliamentary candidates, which you can do now, actually, it's quite easy to write to them all and say, I will be voting based on climate policies. They'll move into the permissive environment we create for them. But the days, in my view, are over where politicians led. I don't think they do. I think they'll follow, and it's for us to show them where to go.
So we have another question. What do you think are the best agricultural methods to produce large supplies of organic and seasonal food?
That's a really, really good question. Right. There's a lot of discussion about this. So the first is that to make things local and seasonal, regenerative agriculture is a much used phrase, but we moved into a phase of mass production of food with mechanization and pouring fertilizer on ground, ammonium phosphate and so forth, and frequent tilling, mechanization breaking up topsoil, which means that 1% of it blows away every time you till it, tractors moving off drag soil away, and the pesticides and those nutrients actually start impairing crop production. But everyone was wedded to this idea, and as people have now started moving back to less mechanized, more open tilling, less use of chemicals and so forth, they're finding the soil microbiome is becoming richer and crop yields are going up. So this isn't an either or. One can go back towards this sort of regenerative agriculture and actually improve crop yields as well. That involves as well caring for insect populations too, because we've been destroying those, and without our pollinators, we're rather stuck as well. It's not without risks, because as we've seen this winter, flooding can destroy a crop, so can a cold spell, so can a sudden heat wave. But we do have to expand agricultural production locally, i.e. in Great Britain, by doing it. And regenerative agriculture is probably the way forward. There are some extra ways. Crushed basalt, for instance, as rock, helps restore soil quality, but it also absorbs a very, very large amount of carbon dioxide. So there are some thoughts about that. There are also companies trying to recreate the microbiomes of rich soil and spray them all over the soil to encourage crops to grow better and sequester more carbon. But in a short answer, it's going to be regenerative agriculture.
Thank you so much. So following up on this, how does the production of CO2 from keeping cattle for meat compare to the CO2 produced in the manufacturing of processed foods, such as in vegan alternatives to animal products?
Well, very quickly then, we shouldn't be eating ultra-processed anything. And again, some of you will have seen the paper reported widely this morning showing that ultra-processed vegan products are also lethal to our health. They're not good to eat. We need to be going back to simple vegetarian-based products. You'll notice I said plant-based. I'm not going to be telling everyone they have to be vegan. I think you can eat meat, and I think you just need to eat it in the right proportions and slightly differently. So if you're a 5-day-a-week steak eater or red meat eater, or sometimes 15 or 20 if people are having sausages for breakfast, bacon sandwich for lunch, and some meat in the evening. Firstly, you can cut down to some meat-free days, and to reduce it, you could actually say, well, actually, for some of those meals, I'm going to be eating poultry instead, or pork. You can start making those changes to shrink your carbon footprint. The big issue essentially is plant-based. Of all of those things of which I've just spoken, whether it's shipping or processing, it's the plant-based bit that's the really big ticket item. And the local and seasonal bit comes second to that as well. So you're still better to be eating vegetables that come from abroad by and large than you are to be eating ruminant meat, for instance, even when it's more local. So that's the main message. Of course, be sensible. If it's tender stem broccoli flown in from Kenya in the middle of winter, that's probably not your best purchase. You might be better to be buying a large head of cauliflower or broccoli from your local greengrocer.
That is very, very insightful. So we have another question. How do you think developing/emerging countries will be able to adapt to climate change and switch to become more renewable, massively reducing their CO2 emissions in a timely manner, especially since many of them are in the middle of their industrial stage of development, whereby fossil fuels are a major source of energy for them?
They can't. It doesn't matter whether the West behaved badly or whether we went there first. It's bad, and it's bad luck, and it's more than bad luck, actually, in many different ways too. But it doesn't matter. The atmosphere doesn't know where the CO2 comes from. And we just simply can't be chucking it in wherever it comes from. Now, part of the problem will require systemic change in, well, first in the leadership of those countries, because some of them are not interested in doing the right thing. But we also need to change some of the banking sector. So that's your world by the sound of it, if you're an economist, because you can raise bonds and funds in a developed nation to go for your solar powered, your solar PV park, or your concentrated solar power, or your wind or wave technology, or whatever renewable it might be. But in less stable countries with less strong economies, the risk is considered high. And therefore, the interest rates on that lending are very, very much higher. And that prevents many of those countries making the right choice, because the cheap choice for them will be to stick up another coal-fired power station. So this does require Western and developed nations, particularly, to reconsider the way they finance these other countries and accept some of the risk, because we all get harmed when those countries have to make the wrong choices. So we have to work together is the answer. Rather than just blaming these other nations, we need to increase the flow of capital and make that capital cheap, as it were, in terms of its interest rate. So we need to work in partnership for that. But it also does require leadership from those countries too, and we're not seeing it.
Definitely. Now, going back onto plant-based diet. So someone has a question regarding this. So if plant-based diet is by far the best thing you can do for emissions, and we are in such a catastrophic position, why would you not strongly suggest everybody completely cut all animal products from their diets?
Okay, there are two questions to that. The first is this, the realpolitik, in that if you're trying to get mass movement and reduction in greenhouse gas emissions, it's a message that's unpalatable to many. So if you say an absolute, most people will ignore that message. So if you say you should never, ever fly in an aeroplane, people just stick their fingers in their ears. And if you say you can only ever eat vegan food, most people will say, well, I'm just going to carry on as I am then. So the messaging is important. And it does seem that if you encourage people to make shifts in their diets, that very often people start and then they start making progressive changes to move down. So I'm not vegan, but I very rarely buy any meat at all. I'll eat it if it's served for me, but I very rarely buy it, for instance. And I've gone most of the way down that journey. It's also an important thing if we are as doctors to be saying, well, let's suppose I did say to you, well, you should eat a vegan diet. It does take quite a lot of scientific knowledge to do it safely, because essential amino acids and essential fatty acids are not found in every single foodstuff in the concentration we require. My elder son was a vegan and a near professional rugby player. So he managed to do that despite being vegan, but he really had to understand where he got his vitamins, where he got his essential fatty acids and amino acids from, so that he didn't become deficient. So B12, for instance, you get from red meat. It's hard to get it from some other sources. Supplementation is there in milk for some vitamins, and in some oat milks it isn't there. So it requires a little bit more knowledge. But it's for those reasons. I'm not going to stand in the way of anyone who wants to be vegan, though. But what we all need to do is just making that shift. By the way, it's not the biggest thing we can do. I mean, it's very hard to say, well, what's the biggest thing? It's certainly one of the big things. But transport is a big issue, for instance, for an aeroplane flight. If you do online, we'll find carbon calculators where you can see where your footprint is generated. And for most people, if they, I don't know, take a return flight to New York, they'll find it very difficult to take 1.6 metric tons out of their emissions that year from any other way of doing it. So there are some big chunks we can all go after.
Thank you so much for your answer. I think we will be rounding up with the last few questions. So given the impacts are most likely to be felt on the very young, how would you educate them to avoid them being scared, given the catastrophic impacts you have highlighted?
Yes, so I think firstly, I'm not sure that the impacts will just be felt on the very young. I'm 62. I'm feeling the impacts already. We're already seeing the economic impacts, and I think these are going to get dramatically worse. I don't think I'm going to be spared from this. So I think we're all in it. The younger people like you must feel angry and disempowered because you don't have, I'm guessing, an investment fund and a pension and a mortgage, and you're not hopping on a plane every week 2 times to go to business meetings. So you sit there presumably thinking, well, what can I do? You must use the agency you have got. So you can move your bank account. If you're in rented accommodation, you can make sure it moves to 100% renewable. You can change your diet. You can change your transport policy. But what you can also do is leverage change amongst those around you. That might be parents and loved ones, brothers and sisters and close friends, and make sure they all take that action. And you can work with your employer or the place in which you work. Now, you're lucky in UCL because UCL, I can tell you, are really, really serious about this. So they're already 100% renewable on power. They're moving to the, as you know, the plant-based campus. They really are trying to make those differences. So they don't need any bullying. But actually, the students were very instrumental in this. 10 years ago, you know, they took some pretty direct action with a provost, and it did force change. We can all, though, work, your parents can work with employers. Who do they work for? Well, I work within the NHS, so I can take a national leadership role, but I can also work with the NHS trust in which I'm working to say, how can I move your power? How can I change your procurement? And I can speak to the companies that service us to say, how can we work together to make these changes? So we need to do, you know, everything everywhere all at once. But for young people, it's using your agency with those around you. And remember, if you talk to advertisers, you are the most powerful force there is. Because if you want to change the behavior of an adult, you get a young person to do it.
Thank you so much. I think that will be our last question for now because time is running out. So yeah, we'll need to conclude here. So thank you everyone for joining us today. And before you go, we kindly request your feedback on today's session. A survey will be sent to everyone shortly after the event, and we will greatly appreciate your input. So many thank you to everyone who shared their comments and questions, and a special thank you to Professor Montgomery for delivering an excellent lecture. So I am wishing everyone a very wonderful evening.
Thank you for having me.
Bye, everyone.
Bye.